This is the video solution for the uniform circular motion example problem. Remember, uniform circular motion is the one where the velocity doesn't change. So here's the problem. In a special stunt at a drag race, a 72.5 kilogram stuntman holds on to the rear of a car as it drifts around in circles. He drifts in a circle with a radius of 8.5 meters with the speed of 11.2 meters per second. What force must he hold onto the car with? So here's the strategy. To begin with, he's going in a circle, so that tells me it's circular motion, so I have all these equations with F equals ma. And the question says for me to find the force. So when I'm finding the force, I only have one equation, F equals ma, but I don't have the acceleration. So I'm going to have to use one of my other equations with acceleration in it, find that first, and then calculate the force. So now I need to look at the units for some clues for help determining my list of givens. So I'm looking at my givens and looking at my units. The first thing I see is 72.5 kilograms, so that tells me that the mass is 72.5 kilograms. The second thing I see is the radius is 8.5 meters. So here's the radius at 8.5 meters. And finally it tells me he's moving with a speed of 11.2 meters per second. So that speed translates into the equation of velocity. So I'm looking for the centripetal acceleration and the centripetal force. So two steps. One, calculate the acceleration. Two, calculate the force. Alright, now to find my equation for the acceleration. I need an equation with all my list of givens. So I'll look at the first equation. It has AC in my list of givens, so that's good. Velocity is in my list of givens, that's good. The period of motion is not, so I can't use the first equation. Second equation, AC is in my list of givens, because it's the unknown, so it's in my list. R is in my list, T is not, so I can't use that equation. Third equation, AC is in my list of givens, velocity is in my list of givens, and so is R. So that is the equation that I want to choose. I want to choose AC is equal to V squared over R. Next, plug in my numbers. So that the AC is 11.2 meters per second squared divided by 8.5 meters. Then show my acceleration to be 14.75764706 meters per second squared. That's the end of step one. Step two was to take that number and put it in F equals ma. So I'll write my equation down and then write my equation with numbers and units using my acceleration with all the decimal places. And that gives me a centripetal force of 1069.93 newtons. And with sig figs that translates over into 1070 newtons.